This is RD Sharma solution, class 12th probability we are taking, and the exercise is the fifth exercise. A husband and wife appear in an interview for two vacancies for the same post. Same post, one post, two vacancies, husband and wife. So two people for one vacancy. One person is a husband, the other one is the wife. The probability of husband selection is 1 by 7. So probability of husband being selected, we call it as H. So probability of H is 1 by 7 being given in the question. Probability of wife being selected, PW we are referencing, it's 1 by 5. So what is the probability of both of them will be selected? Both of them means what? Husband and wife both together. So H intersection W we are talking about. So the probability we are trying to find out is, let's write it in the words. Husband selected here, wife selected here, husband and wife selected here. You have to write it here. I'll show you how to write that. So this is equal to, because these are independent events, this will be PH multiplied by PW, and since the probability is already given, just multiply 1 by 7 with 1 by 5, and this gives you 1 by 7 5 is 35. So this is how this will be done. So husband will be selected is the first one. Second one, wife will be selected. So we are calling it as H. I called it this as W, and both will be selected means intersection will be taken, and the independency of the event makes it just multiply two probabilities of being selected. So we are doing the same scenario because it is 14.1, 14.2, 14.3. Three parts are there. So what is the probability that only one of them will be selected? So needs to be select only one. So let me write the probability of husband being selected and the wife being selected one more time. So PH is 1 by 7, PW is 1 by 5. Only one of them will be selected. That is, either husband gets selected or wife gets selected, but not both. So husband, wife should not be selected. When husband is not selected, wife should be selected. So this is the scenario we have to solve here. So H intersection W bar and H bar intersection W, these two different probabilities have to be added. So probability of only one of them will be selected, that is one of husband or wife will be selected. This equals probability of husband being selected and wife is not being selected, and or probability of husband being not selected and wife getting selected. So these are independent events. Let's do this PH multiplied by PW bar for the first one, and for the second one PH bar multiplied by PW. So what is PH here? 1 by 7, 1 by 5 is PW. So let's find out PH bar, which is probability of husband not getting selected. So 1 minus 1 by 7 will be there. This becomes 6 by 7. And PW bar is simply subtract 1 by 5 from 1. So 1 minus 1 by 5. This is the first one, PH bar. Let me write it as 6 by 7. And now here 1 minus 1 by 5 is 4 by 5. So let's write it here. PH is 1 by 7. Let's write this one. PW is 1 by 5. PW bar is 4 by 5. And PH bar is 6 by 7. So what do you get out of it? It's basically 10 divided by 35. So 2 by 7. So this is, you have to write it again, and then only one of them will be selected, will be computed in this scenario. Now the same scenario, as I said, the background is same. Now we have to find the probability that none of them will be selected. This means neither H nor W. H bar intersection V bar, or H complement intersection W complement. This is the simplest thing which is to be done in this question. So probability of getting H being selected, probability of W being selected, and when they are not selected, it's simply H bar and W bar. So we can write them as the separate events because they are independent. PH bar multiplied by PW bar. PH bar is, we have computed it already. 1 minus 1 by 7 was there. So this is going to be 6 by 7. And PW bar is 1 minus 1 by 5, which was 4 by 5. So 4 by 5 multiplied by 6 by 7 will be the result. So when you multiply this, you can get this as again 24 by 35. That's your answer. So this is how you're going to go about it. Please remember, none of them will means first not, second not, both intersection. It's complement. A bag contains 7 white, 5 black and 7 red balls. So let me make a bag just to represent it diagrammatically. So 7 whites, 5 black and 4 red balls. 4 balls are drawn without replacement. Find the probability that at least 3 balls are black. So what does it mean? At least 3 balls are black means we need 3 blacks because there are 4 being drawn. So either 3 balls are black along with some other color. It can be white, it can be red. So let's assume that the 3 are black. The first one comes out to be, it can be a white or it can be a red, and that these can come in any order, at least 3. Now 4 black color can also come, at least means 4 also can come, 4 black can come. So 4 black balls. So it can be black, 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 or all of them can be or should be black. Now this first one can be white or red, the other can be the other three can be the black balls, or you can have first black, second white or red, then black, black, or first black, second black, then white and red, and then black, or first black, second black, third black, and the fourth one any of white or red. So these are the 4 different probabilities. You have to just multiply and add. This you can do, but you can do from the observation or the experience we have. We know that all these 4 are going to come same. So just find one probability, multiply it by 4. So what we are suggesting here is probability at least 3 black balls is equal to probability of exactly 3 balls which are black. So exactly 3 black balls. The other one, which is the leftover, that is the 4th one, can be any of it, white or red. And probability of all 4 blacks has to be added. These are the 2 possibilities that needs to be added. Now just take any of these multiplied by 4, because the probability is going to come same. Even if you try doing this W, B, B, B plus B, W, B, B, like all these probabilities, if you compute, then multiply and then add all of them. So all of them in these 16 total balls, 11 are the white and red. So the probability of getting a white and red is 11 by 16. Now then next 3 has to be black, but 1 is already been drawn because it is without replacement. So black is how many? There are 5 blacks. So 5 by 15. Now 2 are taken from 16, so 14 are remaining. 1 is taken from black, so 4 are remaining. Now 3 balls are being drawn, so 13 are remaining. 2 out of 5 black balls have been taken, so 3 divided by 13. Now this is 1, 2, 3, 4. And since these arrangements can be done in 4P1, now you tell me it should be 4C1 or 4P1. That's a question for you. So that will come as 4. I hope you got the idea. Just compute one of these and multiply it by 4. Or if you want to give more explanation, just take one, say compute 1, compute 2, compute 3, compute 4 separately and add them. This is going to come 4 times only. Now 5 by 16 is the first black ball, because 5 are black balls, 16 are there. Then 1 is being taken, 4 by 15. 1 is being taken, 2 is being taken, 2 are being taken, so 3 by 14. 1 more is being taken, so 2 by 13. So this black is quite easy because there are only 4 blacks. The first part, which is the exactly 3 black, you need to just understand that thing. So when you compute this computation, I hope you'll be able to do that, and that is going to come as 23 divided by 364. So this was a good question. This 4 multiplied is simply this WR, black, black, black. W oblique R is either W or red can come. Similarly, what you can do is you can just compute individual probability, multiply them. This is just for one case. Then you again multiply the probability of B1, WR2, B3 and B4. That is separate probability needs to be multiplied. And then all these 4 probabilities which are going to come are to be added. That is, the third one will be the black, black, white or red, and then black. So these all 4 have to be multiplied. Means the row which you are seeing, all these rows needs to be multiplied and the columns needs to be added. So these are different probabilities that are going to come. And the better thing is just to compute one probability multiplied by 4, because eventually the result will be same. So I took a shortcut. You can take a shortcut or a long cut. A, B, C are independent witnesses of an event which is known to have occurred. These are independent witnesses. A speaks the truth 3 times out of 4. B 4 times out of 5. C 5 times out of 6. What is the probability that the occurrence will be reported truthfully by majority of 3 witnesses? So probability of A telling the truth is 3 out of 4, 3 by 4. Probability of A not speaking the truth or uttering a false is 1 minus 3 by 4, which is going to come as 1 by 4. Now probability of B saying the truth, 4 out of 5. So 4 divided by 5 is PB. How about PB bar? That is B not saying the truth. This will be 1 minus 4 by 5, 1 by 5. Coming to the C. C probability is 5 times out of 6. So 5 divided by 6 it will be. And C not speaking the truth is 1 minus 5 by 6. 1 minus 5 by 6 is what? It's going to be 1 by 6. So what is the probability that the occurrence will be reported truthfully by a majority of 3 witnesses? So there are 3 of them, A, B and C. So in these 3, majority means either A or B says the truth, C doesn't, or A or C says the truth, B doesn't, or A does not speak the truth, B and C say the truth. A lies, B and C say the truth. Now majority means what? These are 3 cases which we understood. But one more thing is, all of them are saying truth. Let all of them say the truth. When they say the truth, this is also majority. Majority is basically 2 out of 3. So even if 2 of them say truth, this is majority. But if all of them are saying truth, this is also majority. So this is, we have to write in the form of probability. The probability of majority speaks truth, or majority of the 3 witnesses speaking the truth, you can write whole of it or in the short also. This will be probability of 2 speaks truth, 2 are speaking truth at a time and 1 is denying, or all of them are speaking the truth. So this is going to be equal to this, all whatever I have written, I am just writing it here. PA intersection B intersection C bar plus PA intersection B bar intersection C, then probability of A naught, that is A naught speaking the truth, B and C are saying the truth. And finally, all of them are saying the truth. So PA intersection B intersection C. Now this can be separated. It's PA multiplied by PB multiplied by PC bar. And if you remember or recall, we have already computed all these values when we started this question. This is going to be, the second part is PA multiplied by PB bar multiplied by PC. The third term is PA bar, because these are independent units. So PA bar into PB multiplied by PC. The final one will be PA multiplied by PB and multiplied by PC. Now all these probabilities are being computed already. Just replace the values here and you'll find the result. So PA is 3 by 4, PB is 4 by 5, PC bar is 1 by 6, PA is 3 by 4, PB bar is 1 by 5 and PC is 5 by 6. Now PA bar is 1 by 4, PB and PC are 4 by 5 and 5 by 6 respectively. And PA into PB into PC, it is already given in the question, 3 by 4 multiplied by 4 by 5 multiplied by 5 by 6. So just write it here. These 3 values are being multiplied. And when you compute these, concept is important. The computation, I hope you'll be able to do. The final value is going to be 107 divided by 120. Alright, these are the final value, which is the all of them speaking the truth. So this was again a good question, and this is how it needs to be done. This question will be taken in the next discussion. Till then, thank you so much. Have a good one.